In section 3.2, we explore relationships between two quantitative variables. In the example here, we have 40-yard dash times and long jump distances for a class of 12 students, and we're being asked to make a scatter plot to display the relationship between these two variables. We can see in the table here, this dash time and long jump distance is paired, meaning that both of these values, for example, are for a single student. This would be for a second student, on and on. All right, so to start, when we make a scatter plot, we want to label our axes and create our scales. So when it comes to creating our scales, we're going to look for the minimum value and the maximum value in each variable. So for dash times, we don't need to start our axes at 0, 0. Instead, we're going to scale this to accommodate the minimum and maximum. So from 5 seconds to 7.5 seconds will accommodate that minimum and maximum. All right, for long jump distances, here's our minimum, here's our maximum, those same two. Okay, so we want our scale large enough where it can fit both of those. All right, but again, we don't need to start this at 0, and we don't want to start it at 0 because that's just going to lead to a whole bunch of blank space in our graph. Once we have our scales, we can plot each of those dots. All right, and each one is a single student. So 5.41, 171 is this dot right here. If we look at this one, 6.44, 92 would be this guy right there. One of the main questions we'll be asked when we're looking at a scatter plot is either to describe the relationship or describe the association. Back in chapter 1, we talked about describing a distribution. And when we're asked to describe a distribution, we use the acronym SOX, shape, outlier, center, spread. When we're asked to describe an association or a relationship, we use the acronym FUDS for form, unusual features, direction, and strength. So what do each of those components actually mean? Well, for form, we're going to say, is this a linear relationship or a nonlinear relationship? We want to see, is there an apparent curve in those scatter plot points, all right, or are they generally moving in the same direction in a straight line? Unusual features, we're looking for gaps, clusters, or individual points that just don't fit the rest of the pattern. Direction would be positive or negative, or in the case that it's just scatter with no discernible direction, we could say neither. And then strength, we pick one of weak, moderate, or strong. An association that's strong is going to have points that are really close to a line of best fit. And an association that's weak is going to have them very spread out. A lot of times we won't even be able to determine a direction if the association is very weak. Knowing that, let's describe the relationships in each of these two scatter plots. So for the first graph, we have a positive association because these two variables are increasing together. As weight increases, the price increases with it. It's nonlinear because this isn't making a straight line, and instead we can see there's a curve to this association. As for strength, on the left side, it's really strong. Those points are really close to a hypothesized line of best fit there. But as we move to the right, it gets a little more spread out. So I'm going to hedge my bets here and say that this is a moderately strong association. Lastly, anytime we describe an association or a relationship with FUDs, we want to make sure we include context in the same way we did when describing distributions with SOX. That said, the relationship between weight and carats and price in thousands of dollars is positive, nonlinear, and moderately strong. Right? This hits 3 of the 4 things in FUDs. Doesn't mention unusual features because there's none in particular. If we wanted to say maybe this guy he's a little bit farther away than the other ones. It's also good to make some kind of general statement like this one. Variation in price increases with larger weights. That's just saying that these points over here with higher weights and carats are more spread out than the points with lower weights and carats. Back to that example that we started this set of notes with, we have the relationship between dash time and long distance jump. We can see that this is a negative association. It's decreasing left to right as dash time increases. Long distance jump is decreasing. It's moderate. It's a bit spread out around that line of best fit, but it is linear. It's making a straight line. No unusual features to spot. So we would write something along the lines of the relationship between dash time in seconds and long jump distance in inches is negative, linear, and moderate with no unusual features.